Hi everybody. I had practicing on one of these power distribution companies that actually installs high voltage transformers and stuff like that, and throws the power lines and you know, all that high power stuff, high voltage. So from there I got these three transformer bushings. It's actually the connector here and goes out to the top, and if you just unscrew it, you have something like that, and take that off, you see that actually goes in between the hole, and that's the thing here that keeps the oil out. That's pretty good. Here's my transformer box, and I got that little standoff as well. They've thrown this away because it got a little surge on the side. Cut the end off, arced over. And the same company actually installs the electric meters, and they actually changing some of their electric meters now, and they throw away a bunch of electric meters, a lot of them working, no problem with them. Here you can see some of the electric meters that took. This one is a Landis+Gyr. This one is a Kamstrup. That one is a Enerment. And that's a old electrics. And why did I took all of these electric meters? Yes, why did I take all of these electric meters? These are all Kamstrup ones. These are very good. The best quality of electric meters they have. They are made in Denmark. And because I took them, these four actually, is I'm going to blow them up. I'm going to see how much power they can take before they blew up. This one's very old. This has been outside for a while. As you can see, the screws actually rusted away. But they will make that going. It still rotates a little bit if you can see it. So yes, I'm actually going to overload them. See how much current they can take and voltage. And I'm going to do a surge test as well with my defibrillator capacitor and see if they can handle surges in the line. And yes, they're three-phase. Not that one. This one is a single phase. So this one will actually have another test, special one with a MOT, a voltage. This other one, three phases, all of them. I'm going to take some more of these electric meters, three-phase one, and three-phase of that one, because that one's a single phase. They had a lot of three phases as well, but I took this one because that was 000, was never used. Yep, I'm going to do a high current test on one phase, a surge test on the second phase, and guess what, the third phase. I'm going to just plug it in to see if it actually still works, if it actually measures anything, or if it has completely blown away. So that's good with three-phase. High current test, high voltage test, and just a test to see if it works. Still works. And half the electric meter is, 2/3 of the electric meter has burned away. And here in Finland, do you think that somebody comes outside your house and watch your electric meter? And this was the old system. They're changing this. They had something called the turtles in them. And they look something like this. It's just a circuit board. And the complete turtle was just a little box that came under the electric meter. And this turtle actually is the pulses which comes out from the electric meter. It has a separate connector in here. You can see that little blue thing in there, and that thing connects into that, and the pulses goes into that, and it actually makes a little ripple signal back in the power line. As you maybe see, Rodolco 2007's Zillweger motor generator that actually puts a ripple in the system. This thing works like something similar like that, but much less harmonics and a higher frequency as well. And why is it called a turtle? Yes, because it actually takes 27 hours to send the metered power to the company. That's how long it takes. That's why they're changing it. The new thing actually sends a message every 5 minutes. So much faster and much more precision than these things. And I took a lot of these turtles because they are very good. They had a large capacitor, 2 MOVs and 2 IGBTs. I've got some more of these turtles. There are more. Take that MOVs and IGBTs out. But where's the capacitors? Here they are. Look at that. That's a lot of capacitors. And if you want, they're just 5 microfarad, 250 volts AC, 50 to 60 Hertz. If you saw my previous video with that high current toroidal, and here's the toroidal, and that's the wire. Why did I take off the wire? As you saw in the video, there was pretty short wire actually. It was just a little bit out of the transformer. But now in the distribution power company, I got even more of that wire. Look at that. That's nearly 3-4 meters of that stuff. And I got that good nice connectors as well. That's one connector, and I got another connector here. That's how they look like. And yes, this one is actually aluminium, for aluminium wire, but I just put copper in it. Yes, 300 square millimeters. The bottom one. And the top one is 120 square millimeters. So you can actually put 4 wires in this. Very good connectors. And that part here actually is supposed to be on the transformer bushing. Now I'm going to connect that one on this and see if it gets any better. I want to keep the distance from the connector to the electric meter as short as I can, so they get more current because the voltage is so low. This wire is 185 square millimeters. I don't know how many gauge that is, but 185 square millimeters. Yes, I got it. So I'm going to put that on this and do a little test. Thanks for watching.